And good morning, class. So for today, we'll be talking about pollution and toxins. So this will be topic 4 of environmental chem. Um, I can't create a very long video, so what I will do is I will just cut this into two sections. But I will be uploading those two videos and just watch out. Just check your news feed. So for today, we'll be talking about pollution. Now, you can think of it. You can think of pollution this way. I have a piece of paper. If I have two pieces of paper and then just put them on the table, it's okay, right? Um, but if I have, let's say, 3 million or 1 billion pieces of paper, post-its, um, then I have a problem, right? So you can think of pollution as, you know, a good thing, a good material can, in a way, be a pollutant. So that's the thing. Let's say, for example, I have an old iPod Classic. So if I have one of these or two of these, it's okay, right? But if you have, let's say, 10 million, then where would you put it? In more important question, why do you have them? Anyways, but if you have, let's say, 10 million iPods, now that in a way will affect their quality of life, then we can label it as a pollutant. So a good thing or a good material, a good substance, or um, well, depends on the amount. If it affects the way you live, and if it harms a living thing, then it can be considered as a pollutant. So, pollutants are substances that are, uh, substances that will produce a harmful condition to living things. Okay, toxins can create or produce serious health problems and even death. Okay, so how can chemicals be introduced to the environment? Well, first is through agriculture. So we all know that agriculture will use fertilizers. Farmers will use fertilizers, and obviously to kill the insects that will kill the um, that will damage the crops. Then they will use pesticides in order to kill them. If you will do your research, you might wanna check. Um, you might want to go to YouTube and Google cotton farmers in India, and then you will see a lot of links there. They're using really harmful chemicals that somehow produce, like, kids that are quadriplegic, or the kids without legs and arms. So because of those pesticides and for pesticides mainly. Waste, solid waste, wastewater. So that will be mostly from households, but industrial plants will be using wastewater. Well, will be producing a lot of wastewater too. Um, Fuel combustion. So you have fuels. When you burn fuel, and you will hopefully you will still remember this when you go to your higher chemistry in high school. When you burn fuel, the common product will be carbon dioxide and water. But aside from those two, there are other compounds that are produced. Like those can be sulfate, sulfites, nitrate, nitrites. The problem is when they combine with the hydrogen present in the atmosphere, then eventually they can produce acid rain. Industry. Okay, so production plants, those things. Obviously, the more they manufacture, the more waste that they will create, and the more chemicals that will be introduced to the environment. So effects of chemicals in the environment. So you have biological magnification. So um, well, you can think of it this way: if you have a small, so it increase of concentration of a substance as it moves up the food chain. So you can think of it this way. Say, for example, an industrial plant will, dump, let's say, mercury in water, in a body of water, and then the plants there will absorb that mercury, and then the small fish will start eating those plants. So let's say a small fish will eat the plant, okay, and then obviously will be taking in mercury also. And the problem with mercury, it's not like you when you urinate or when you poop, you can just excrete mercury. It stays with you. So what happens is, so those small fish, when they are, you know eaten by bigger fish, then all of the mercury present in the small one will be transferred to the big one, and then the bigger fish will be eaten by a bigger fish, and so on. And and the amount of mercury will increase as you go up the food chain. And that's the reason why we call it biological magnification, because the amount increases as you go higher to the food chain. So you have an example is the chemical DDT. You can just do your quick research on that one. So they were thinking before that it's okay, right? That there's no problem, but eventually they found out that it's gonna be harmful to living things. So now, and that's the thing, right? So when we're looking at a criminal, we will assume that the person is innocent unless you prove that person guilty. Now it's should be the opposite for chemicals. The chemical should be assumed guilty before you introduce them to the environment. I'll give you one example. It happened before, 25 years ago. I think I said that already. An artificial sweetener was introduced to the market, and eventually, they found out after 20 or 2 decades, 20 years, 2 or 2 decades, they found out that that chemical or that artificial sweetener um, is cancer causing. So it can cause cancer. And then what will you tell those people who bought those artificial sweeteners? I'm sorry, right? That's the reason why we need to assume that they are guilty before we introduce them to the environment. So an example of biomagnification here. So you have the zooplankton. So notice it's only 0.0000003 ppm, and then as you go higher to the food chain, um, y- now the parts per million became 25. Now, if you will try to divide 25 divided by, okay, let's do that quickly. 25 divided by 0.00000, so five zeros and three. Okay, now it's around 8 million times the concentration when you started at the very bottom. So, and that's huge, obviously, right? Um, and here are some of the effects here. So, okay. So usually when they have this, and then there are some chemicals that will prevent, the formation of shell, or somehow will make the eggshell softer. And this is what happened here. Okay, and whatever the mom is eating will be transferred to the baby kids too. So now, so the chicks too. So the chicks will now be producing eggs with, maybe less carbon because they can't absorb they can't produce a more sturdier shell, right? So that can be a problem too. um, so in the early 1950s, the people in Borneo suffered from malaria. The World Health Organization had a solution: kill the mosquitoes with DDT, and this is what happened, right? And then eating geckos cause more DDT to accumulate, and this is basically what accumulation looks like, right? You start from here, caterpillars will be, eaten by parasites and those things, and then eventually you have biological magnification. So that's an increase in concentration as you go higher to uh, um, the food chain. Okay, measuring toxicity. So how will you know if it's toxic or not? Uh, what the common well, a common way of measuring toxicity is LD50, meaning it's lethal to 50% of the population. So say for example, if they have a sample of rats, right? Sample of rats, and then they want to know how toxic a gas is. They will be placed inside a chamber, and then so this amount of gas will kill 50% of the population. So that's the amount. That's the LD50 amount. LD50 amount. Okay, lethal dose 50 means 50% amount of substance that causes 50% of the group of test organisms to die if given a specific dose. Okay, so it's LD50. So the less needed to kill test organisms. So the lower the LD, the less needed to kill an organism, which tells you that it's more powerful. It's more toxic. Okay, the more toxic the substance, the lesser amount you will get, the lesser the LD50. So say for example, LD50 of 150 is more toxic than LD50 of 200, because the smaller the amount, the more toxic it is. Meaning you only need a small amount to kill 50% of a sample population. Hope that's clear. For concentration, it is the amount of substance given in a it is the amount of solute present in a given volume of solution or solvent. So think of it this way: you put let's say a tablespoon of sugar you place it in a cup of water. So the sugar will be the solute, the volume or the solution will be the well the solvent will be the cup of water. So you put 1 tablespoon of sugar in 1 cup of water. So you now have a solution. So obviously, the more sugar you add to that 1 cup of water, the more concentrated it is. So you've prepared Kool-Aid before, powdered Gatorade, and this would be so just an example here, right? Diluted meaning you have less solute or the substance you are dissolving will be lesser, and then as you increase the amount of solute, it becomes more concentrated, like this part here picture. So ways to measure is grams per liter. So obviously the higher the number of grams or amount of grams or mass per liter, the more concentrated it is. So let's say we've been talking about it, like for COVID-19, right? Dr. Hinshaw will tell you, okay, use at least 60% or higher for like 60% or higher percentage alcohol in order for it to be effective for killing the virus or the bacteria, right? Um, so we use percentage too. So what does that mean? So for every for every 10 ml of alcohol solution, you have 6 ml of alcohol. So again, for every 10 ml of alcohol solution, you have 6 ml alcohol. So that's 60% alcohol. You know what? Do your research. According to one study, it's 70% that is the most lethal. Okay, the most effective when it comes to killing bacteria and viruses. So parts per million. It's a milligram, 1 milligram per liter. So it's one part substance in 1 million parts of water. Okay, so why do they need to measure it that way? But because the thing is, you don't need, like, there are certain chemicals or elements or metals that you don't need a lot in order for them to cause huge problems, right? And that's why they need to measure it in parts per million, so they can easily see whether it will cause a problem or not. So 1 milligram of substance. So always remember, parts per million is 1 milligram of substance for every 1 liter of water. So one part per million. Okay, you can think of it this way: one drop of food coloring in a bathtub. Bathtub. So I don't think that will be right. It will be that evident, or it will be that obvious, right? So one drop of food coloring in a bathtub. Um, so how to calculate them? If you add zero point 0.1 ml of DDT to 2,000 ml of water, what is the concentration in parts per million? So you can do it this way. Okay, zero point 0.1. Okay. So cross multiply this zero point 0.1 times 1 million. So that will be equivalent to 100,000 divided by 2,000. Um, and that will be 50. So the amount is 50 parts per million. Okay. Parts per billion. So that's another way of expressing concentration. Parts per billion is one drop of food coloring in a swimming pool. Okay. Parts per trillion is comparable to one drop of food coloring in 1,000 swimming pools. Okay. So this is an example of biological magnification. So you started with 0.003 and now it became 25 parts per million. So we'll stop here for now. So I don't think my account will allow me to record longer than 15 minutes. And I'll be uploading this video. So wait for the second part of the video. If you have any questions, just feel free to shoot me an email, or go to our Google chat. Okay. God bless. Thank you.